Linear probabilistic modeling. This long tongue twister of sorts sounds scary, but in reality, it is a useful tool that helps approximate a linear distribution. The linear probabilistic model is a case of regression, where the expected value of y is a linear function of x being the variable we manipulate and y being the dependent variable. Linear probabilistic modeling is expressed through this equation here, where b0 is the intercept, b sub 1 is the slope, and epsilon is the random deviation. This equation is similar to the y equals mx plus b we learned years ago. Linear probabilistic modeling can take many forms, such as finding the relationship between high school GPAs and college GPAs, or the relationship between graduating from college and earning a high income. In the context of engineering, say we observe the relationship between the stress in a beam and the time until failure. Intuitively, we know that with a greater weight comes more stress in a beam, and with that comes a quicker failure. Plotting these points will show us that there does tend to be a linear trend between the stress in a beam and the time to failure. The dots on this plot represent data points from multiple experiments done to test how long it took for the beam to fail. The deviation from the line shows the variation from the true regression line and represents the random error of data. A point below the true regression line represents a negative value for epsilon, while one above the line represents one that is positive. The linear regression line is determined through the least squares method by first taking the mean of the x variables and the mean of the y variables. The linear regression line must go through the point mean of x, mean of y. Next, we find the distance of the means from the points on the line, each one at a time. Then, we square the distance between the mean and the values of x, as well as multiply the distances x minus x bar and y minus y bar. Dividing the sum of x minus x bar times y minus y bar by the sum of x minus x bar squared will result in the slope of the regression line. This method is the most common method for fitting the regression line to data because it minimizes the sum of squares of the deviations. We can also note that because the deviations are squared before they are added together, there are no cancellations due to positive and negative numbers. The linear probabilistic model is such a useful tool for engineers and is definitely a tool worth learning.